This is Algebra Lesson 8-8, Factoring by Grouping. Some polynomials of a degree greater than 2 can be factored. In Lesson 8-4, you factored trinomials of the form ax squared plus bx plus c by rewriting bx as a sum of two monomials. You then grouped the terms in pairs, factored the greatest common factor from each pair, then looked for a common binomial factor. This process is called factoring by grouping. We can extend this technique to higher degree polynomials. Since you can use the distributive property to multiply, you can also use the distributive property to factor by grouping if two groups of terms have the same factors. So to factor by grouping, you basically are looking for a common binomial factor of the two pairs of terms. For example, if I had x cubed plus x squared plus 2x plus 2, I could group this polynomial first two terms and last two terms. In the first two terms, my greatest common factor is x squared. When I factor that out, it leaves me with an x plus 1. In the second two terms, the second binomial, the greatest common factor is 2. When I factor that out, I'm left with x plus 1. So my common factor is x plus 1, and what is left over is x squared plus 2, and therefore I have factored it. A couple of things to note. If I have a plus b, that's the same as saying a negative, parentheses, negative a minus b, because if I run a negative through the negative a minus b, I get a plus b. A minus b is the same as saying negative a plus b. Okay. Parentheses, negative a plus b. Or it's the same as saying a negative parentheses b minus a, or it would be negative b plus a. Okay, there's different ways of saying certain things with addition and subtraction, and if you recognize those, then you can determine whether or not you can combine terms. So let's look at some factoring by grouping. We're going to look at factoring by grouping. Factoring by grouping is oftentimes used when you have more than 3 terms, like 4 terms or 6 terms. You're going to look to group things together so that you can factor something out. So if I look at this first problem, 2x cubed plus 6x squared plus x plus 3. It has 4 terms. So I'm going to look to factor by grouping. And I always start with first two, last two. Sometimes it doesn't work out that you can group your first 2 terms together and your last 2 terms together. Sometimes you have to rearrange the polynomial in order to get it to work that way. Most of the time, if the polynomial is written in standard form, it will group first 2, last 2 if it's going to group. So first 2 terms, last 2 terms. And I always put my sign before my last 2 terms. My greatest common factor out of 2x cubed plus 6x squared is 2x squared. I can take a 2x squared out of that polynomial, that binomial. 2x cubed divided by 2x squared leaves me with just x. 6x squared divided by 2x squared leaves me with 3. The greatest common factor out of x plus 3 is simply 1. 1 divides into all of those, and it leaves me with x plus 3. Now I have my common term, just like we factored before when we were factoring in the form of ax squared plus bx plus c. So my common term is x plus 3. And what is left over? 2x squared and the 1. So that's how you'd factor something that has more than 3 terms. Factoring by grouping is actually fairly simple. And since we've done quite a bit of it when we factored polynomials in the form of ax squared plus bx plus c, you should find this to be fairly straightforward. Problem number 2, 4a to the third plus 10a squared plus 6a plus 15. Again, I'm going to factor by grouping my first 2 terms and my last 2 terms. If I look at 4a to the third plus 10a to the second, I could factor out a 2 as a number, and the greatest number of a's I can take out is a squared. So 4a to the third divided by 2a squared. 4 divided by 2 is 2. A to the third divided by a squared is a. 10a squared divided by 2a squared. 10 divided by 2 is 5. A squared divided by a squared is just goes away. It's 1, and 1 times 5 is 5. Out of 6a plus 15, I can take out a 3. So 6a divided by 3, 6 divided by 3 is 2, leave my a. 15 divided by 3 is 5. And there we have, there's our common term again. 2a squared plus 5. And everything left over right here and right there. So 2a squared, excuse me, 2a plus 5, not 2a squared plus 5. Silly me. Eraser. It still doesn't want to erase. Eraser. There we go. There's my eraser. So 2a plus 5 and then 2a squared plus 3. And that is the factorization for that problem. Alrighty, let's move the page down a little bit and look at these last two problems. X squared y squared plus ay squared plus ab plus bx squared. That one looks a little odd, doesn't it? No numbers, just lots and lots of variables. Doesn't mean it can't be factored. Again, if I look at this, I started out with an x squared y squared, then I went to y squared, then I have no y squared, so you're like, maybe I should rearrange the variables. No, I wouldn't try rearranging it unless it doesn't work after you've tried to group it. So I'm going to group this first two, last two. And out of x squared y squared plus ay squared, I can take out a y squared. So x squared y squared divided by y squared leaves me with x squared plus a y squared divided by y squared, which just leaves me with a. And then the second binomial, ab plus bx squared, it looks like I could take out a b. If I divide out a b, ab divided by b is just a. And bx squared divided by b is just x squared. And you might look at me and say, well, we didn't get a common factor, but we did, because x squared plus a and a plus x squared are the same thing, just written in a reverse order. Okay, so my common term is x squared plus a. And what is left over? Y squared plus b. And there we have it. Number 4. Alrighty, if I look at number 4, I'm going to group first two, last two again. First two, last two. Greatest common factor out of 5x to the 4th minus 5x to the 3rd is 5x to the 3rd. 5x to the 4th divided by 5x to the 3rd just leaves me with an x. And minus 5x to the 3rd divided by 5x to the 3rd is 1. If everything divides out, it's not 0. If everything divides out, it's just 1. 6 divided by 6 is 1. If I have 6 people and I have 6 cookies, each person gets 1 cookie. They don't get 0 cookies. They would be a little mad at you if that happened. The second binomial, negative x plus 1, greatest common factor there is going to be negative 1. Because remember, we never want the first term to be negative, so I'm going to pull out a negative 1. Negative x divided by negative 1 gives me a positive x. Positive 1 divided by negative 1 gives me a negative 1. And that way I have a common term, don't I? So my common term is x minus 1, and I'm left with 5x to the 3rd minus 1. And that's factoring by grouping. Factoring by grouping is actually really quite simple. Now that we've basically learned all the different types of factoring, we need to look at things and say, when do I use which one? So, when factoring, you can look for some specific things to help you determine how you should factor a polynomial. So these are the things that you want to look for. Number 1, always look for a greatest common factor. We didn't have any in our 4-termed polynomials, but we might. So always look for that greatest common factor, and if you have one, get rid of it first. Then look at the number of terms. If you only have 2 terms, see if it's a difference of squares. See if the first term's a perfect square. See if the last term's a perfect square. See if there's a minus sign between them. If it is 3 terms, first thing I would look for, is it a trinomial square? Is the first term a perfect square? Is the last term a perfect square? Is the middle term twice the first term times the last term, or the opposite of twice the first term times the last term? If it is, then use the trinomial square formulas. If it is not, then try the product and sum. Okay, if it's in the form of x squared plus bx plus c, find the product of c and the sum of b. If it's in the form of ax squared plus bx plus c, find the product of a and c and the sum of b. If it's 4 terms, try grouping. And last but not least, always remember to factor completely. That seems like an innocuous saying, but you'd be amazed at how many people will think they've factored something completely out and only to find out that they haven't, because it goes even further than they think it does. So let's try factoring. Notice the directions. Factor completely, which means you need to factor it till you can't factor it anymore. So let's look at number 5. Well, first of all, it is 2 terms. Okay. First thing that the list said that I should always look for is a greatest common factor. Do I have a greatest common factor here? It certainly looks like it. Looks like I have a GCF of 14a squared. So if I take a 14a squared out of this polynomial, this binomial, 14a to the 4th divided by 14a squared just leaves me with a squared, and 14a squared divided by 14a squared leaves me with 1. At this point in time, most people think they're probably done, but you are not done. Because if I look at this, a squared minus 1 is 2 terms. The first term is a perfect square, the last term is a perfect square, and there is a minus sign between them, which means this is the difference of squares. It's an a plus b times an a minus b, where my a term is, coincidentally enough, a, and my b term is 1. So this is going to become 14a squared times a plus 1 times a minus 1. Now it is completely factored. Until we factored out that a squared minus 1, we weren't done yet. Let's look at problem number, that should say 6, not 26. Extra 2 got snuck in there. Problem number 6, I'm just going to get rid of that 2. See, we don't see a 2, it's just problem number 6. If I look at problem number 6, x to the 8th minus 1, no greatest common factor, but it is 2 terms. First term is a perfect square, last term is a perfect square, there's a minus sign between them. So my a term, remember, you always divide your variables in half, so 8 divided by 2 is 4, so that's going to give me x to the 4th. My b term is 1. So I have x to the 4th, it's x to the 4th, not x plus 4. I'm having a really hard time with that today. X to the 4th plus 1 times x to the 4th minus 1. So I have 2 binomials here. X to the 4th plus 1. Well, x to the 4th is a perfect square. 1 is a perfect square, but there's not a minus sign between them. So x to the 4th plus 1 is not going to factor again. So I'm just going to underline it because that does not factor again. But x to the 4th minus 1 does. Okay, now my a term is going to be x squared, and my b term is still 1. So this x to the 4th minus 1 will factor to x squared plus 1 times x squared minus 1. The x squared plus 1 does not factor again, but the x squared minus 1 does. Okay, the x squared minus 1 will factor again because the a term is x and the b term is 1. So this x squared minus 1 factors to x plus 1 times x minus 1. Okay, so the complete factorization of x to the 8th minus 1 is x to the 4th plus 1 times x squared plus 1 times x plus 1 times x minus 1. That was a long factorization, which happens a lot when you have some variable raised to an even numbered power minus 1, because 1's a perfect square. It's also a perfect cube or a perfect 4th. All right, problem number 7. 12x cubed minus 21x squared plus 8x minus 14. Looking for a greatest common factor. Well, there's a greatest common factor for 12 and 21, and there's one for 12, 8, and 14, but there's not something for all of it. So I'm going to look at it. It's 4 terms, so I'm going to group first 2, last 2. All right, greatest common factor out of 12x cubed minus 21x squared is going to be 3x squared. 12x to the 3rd divided by 3x squared is 4x. 21x squared divided by 3x squared is 7. Greatest common factor out of 8x minus 14 is 2. 8x divided by 2 is 4x. 14 divided by 2 is 7. So my common term is 4x minus 7. And what is left over is 3x squared plus 2. Neither one of those will factor again, so I am done. All right, problem number 8. 3x to the 4th plus 30x to the 3rd plus 75x squared. I'm looking at that going, ooh, I know there's a greatest common factor of each, of at least an x or two. But are there any numbers? Well, 3, 30, and 75 are all divisible by 3. So I can take out a 3x squared. So my GCF here is going to be 3x squared. When I take that out, I'm left with x squared. 30 divided by 3 is 10, plus 10x plus 75 divided by 3 is 25. Now you can either choose at this point in time to try to find a special product that works with this if you recognize it really fast, or you can factor it product sum. I need a product of 25 and a sum of 10, which is 5 and 5. So I look at this and go, oh, this is a perfect square trinomial. Perfect square first term, perfect square last term, middle term is twice the first times the last. So my A term is x and my B term is 5, so x plus 5 times x plus 5. And I've got my 3x squared that I started out with that I don't want to forget. Or you could write it as 3x squared times x plus 5 quantity squared. Either one of these is fine. Doesn't matter which way you choose to write it. Number 9. 2a to the 4th plus 14a to the 3rd plus 24a squared. Greatest common factor, 2a squared. So 2a to the 4th divided by 2a squared is a squared. 14a to the 3rd divided by 2a squared is 7a. 24a squared divided by 2a squared is going to be 12. That is not a perfect square trinomial. So now I'm looking for a product of 12 with a sum of 7. 4 and 3, because 4 times 3 is 12, 4 plus 3 is 7. So I have a plus 4, a plus 3, because there's no leading coefficient. And don't forget to bring down your greatest common factor of 2a squared. And I am done with that problem. Number 10, y to the 5th minus 2y to the 4th minus 35y to the 3rd. My greatest common factor here, I believe, is going to be y to the 3rd. So if I can divide out a y to the 3rd, I am left with y squared minus 2y minus 35. So I have a 3-termed polynomial that has no special properties to it. So I'm looking for a product of negative 35 with a sum of negative 2. So the larger of my two factors must be negative. I'm thinking of 7 and 5, so I need a negative 7 and a positive 5. So that's the only way I'm going to get a sum of negative 2 and a product of negative 35. So that leaves me with y minus 7 times y plus 5. And don't forget, we took a GCF out, so we have to put the y to the 3rd at the beginning. Let's just do a couple more. Number 11, 45m to the 4th minus 9m to the 3rd plus 30m squared minus 6m. A lot of times people look at this and go, oh, it's 4 terms, group. I always look for a greatest common factor first. I'm looking at this and I know that 45 is divisible by 3, 9 is divisible by 3, 30 is divisible by 3, and 6 is divisible by 3. And it looks like I can take an m out of everything. So I've got a GCF here of 3m. So I'm going to divide everything by 3m. When I do that, I get 45m to the 4th divided by 3m is 15m to the 3rd, minus 9 divided by 3 is 3, m to the 3rd divided by m is m squared. plus 30m squared divided by 3m is 10m, and then negative 6m divided by 3m is negative 2. So now I'm looking at that going, oh, okay, I can group this first two, last two. And I'm going to change colors of my pen so that you can see how I'm going to group this. So I'm going to group first two, last two. Okay. So my greatest common factor out of 15m to the third minus 3m squared is a 3m squared. 15m to the third divided by 3m squared is going to give me 5m. Negative 3m squared divided by 3m squared is going to give me negative 1. 10m minus 2, the greatest common factor for there is 2. And that's going to leave me with 5m minus 1. So my common term, 5m minus 1. What is left over? 3m squared plus 2. My GCF to begin with, 3m. Now look at it and make sure it doesn't factor again. It doesn't look like that can factor again, so I am done. Number 12, 5t to the fourth plus 20t to the third plus 6t plus 24. There's no greatest common factor in this guy. So I will factor first two, last two, because it is 4 terms. Well, the greatest common factor of the first 2 terms looks like 5t to the third. 5t to the fourth divided by 5t to the third leaves me with t. 20t to the third divided by 5t to the third leaves me with 4. Greatest common factor out of 6t plus 24 is 6. That means 6t divided by 6 is t. 24 divided by 6 is 4. So common term, t plus 4. Left over, 5t to the third plus 6. Alrighty, so I think you're getting the idea of factoring completely, making sure that everything is factored all the way it possibly can be factored. Let's look at an application here. A rectangular prism has a volume of 36x to the third plus 51x squared plus 18x. Factor to find the possible expressions for length, width, and height. Okay, so we need to factor this. So let me rewrite this down here. 36x to the third plus 51x squared plus 18x. There's a GCF in that. I'm thinking 3x. So I will take a 3x out of this. 36 divided by 3 is 12. So x cubed divided by x is x squared. 51 divided by 3 is 17. So 17x. And then 18 divided by 3 is 6. And the x's cancel each other out. So now I'm looking at 12x squared plus 17x plus 6. So I need a product of 12 times 6, which is 72, and a sum of 17. So now, because we have a leading coefficient of more than 1, so we have to do the product of a times c. Okay, so 72, I'm thinking 8 times 9. So 8 times 9 is 72. 8 plus 9 does equal 17. I found my number. So take the 12x squared plus 17x plus 6, and let's factor that. So 12x squared plus 8x plus 9x plus 6. Okay, now we're going to take this and group it. First two, last two. Greatest common factor out of 12x squared plus 8x is 4x. And that leaves me with 12x squared divided by 4x is 3x. 8x divided by 4 is 2. Greatest common factor out of 9x plus 6 is 3. 9 divided by 3 is 3x. 6 divided by 3 is 2. So I have a 3x plus 2 as my common term, a 4x plus 3 as my other term, and don't forget the GCF. We have to put that down there, which is important because this is a word problem and asked us for find the 3 dimensions. If we wouldn't have the greatest common factor, we would only have 2 of the possible dimensions instead of 3 of the possible dimensions. So the dimensions are 3x, 3x plus 2, and 4x plus 3. Those are the possible dimensions of your polynomial. And they'll seem really weird for dimensions. You're like, how would I figure out my volume of my prism by that? Well, if you knew what x was, then you'd know your 3 dimensions, which is exactly what they're trying to work out. Okay, the closure question for this lesson is, what should be your first and last steps when completing the factorization of a polynomial? So what should you look for first, and what should you look for before you've decided, yes, I am done? Those are the 2 things I'm looking for that closure question.